Let's simulate votes for the 2004 Ohio senatorial race. On the right, I have a ShadowTraffic file that generates data to a Postgres table called votes. I have a variable defined called location that uses a new generator called geolocation that creates real locations within a particular country. Here I narrow it to the United States, and for locations within the state of Ohio, I get the output format in terms of its coordinates. When I actually generate the data, the rows that I submit to the table called votes are a voter ID, the latitude and longitude that we just looked at, and the candidate, which is weighted to the actual results of the 2004 election. I cast one vote per 50 milliseconds. On the left, I run ShadowTraffic in development mode on standard out with 10 samples, and I can see that the data looks to be the way that I wanted. I have latitude, longitude, and the candidate. If I turn off the development flags and I actually run it against my Postgres table, I can see that the data is going to start pouring into this votes table. I see the latitude, longitude, everything that I just saw in standard out. Finally, if I actually go look at some of this data sitting in Grafana, I can actually see it start to fill into this heat map. And what's interesting is that you see the cities start to have the most concentration of votes, which makes sense. Most of the population in a given state resides around the cities, and if everyone's sort of voting around the same time, you would expect places like Columbus or Akron or Cleveland to fill in the fastest. And indeed, that's actually what you see in this heat map. And that's how ShadowTraffic geolocation works.